Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about problems on calculation of air quantity required for complete combustion of fuel. So before we discussed about the problems, we discussed main points about how much amount of air required for complete combustion of fuel. So main points we discussed before that, before discussing these numericals. So what is meaning of combustion? So fuel during burning process in the presence of oxygen, it produces heat energy. This process is called combustion. So in this session we discussed about how much amount of air or oxygen required for complete combustion of fuel. So here the main elements generally present in the fuels are carbon, hydrogen, oxygen and sulfur. So the main elements present in the most of the fuels are carbon, hydrogen, oxygen and sulfur. So on combustion of fuels, these elements are converted into gases. That means during combustion process or burning of fuel. So fuel burning in the presence of oxygen, it produces combustion products. And also it gives heat energy. So here, if in case most of the fuels containing, what are the elements? Carbon, hydrogen, oxygen and sulfur. So on combustion of fuel, these elements are converted into gases. So that means combustion products. So what is that? If in case carbon present in this fuel, carbon reacts with oxygen, then gives carbon dioxide. Or if in case hydrogen present in fuel, it converts to water. Or if in case sulfur present in fuel, it reacts with oxygen, then gives sulfur dioxide. So on combustion of fuel, these elements like carbon, hydrogen, oxygen and sulfur present in fuels, these are converted into gases like carbon dioxide, water and sulfur dioxide, etc. So for efficient combustion, sufficient quantity of air must be brought into intimate contact with the fuel. So what is the meaning? For efficient combustion, sufficient quantity of air is required for complete combustion of a fuel. So the amount of air and oxygen. So the amount of air and oxygen required for the complete combustion of a fuel. So it can be determined by considering the following points. So here combustion means fuel interacts with or reacts with oxygen and gives combustion products. This process is called combustion. In this case, it releases heat energy. That energy is used for domestic as well as industrial purpose. So the main elements present in these fuels are carbon, hydrogen, oxygen and sulfur, etc. Most of the fuels containing these elements. So during combustion process in the presence of oxygen, it produces carbon dioxide and water and sulfur dioxide, etc. So for efficient combustion, sufficient quantity of air is required for complete combustion of fuel. So here the amount of air and oxygen, how much amount of air and oxygen required for the complete combustion of the fuel. So how can you determine this one? By following these points. So what is the first point? The substances always combine in definite proportions. Substances always combine with definite proportions. So based on the molecular weight of the substances. Substances always combine in definite proportions, that means oxygen. So it is based on the molecular weight of the substances. For example, here combustion of carbon. If in case in this fuel it containing carbon. So generally good fuel always containing high percentage of carbon, that means it increases the calorific value. So the main constituent of fuel is carbon. For example, in this fuel it containing carbon. So during burning process in the presence of oxygen, what is the combustion product formed here? Carbon dioxide. So the substances always combine definite proportions. It is based on the molecular weight of the substances. For example, here carbon molecular weight is 12 and oxygen molecular weight is 32 and carbon dioxide molecular weight is 44. So for complete combustion, so 12 kg of carbon requires. For complete combustion, 12 kg of carbon requires 32 kilograms of oxygen. 12 kg of carbon requires 32 kilograms of oxygen. For example, C kg of carbon or X amount of carbon. Here you are taking C. So C kg of carbon in the fuel. So how much amount of oxygen required for complete combustion? For complete combustion. So how can you calculate this one? So it's equal 32 by 12 into C. 32 by 12 into C. For example, if in case combustion of hydrogen. So in this case, how much amount of oxygen required? So here, what is the first write on the reaction of this one? So hydrogen, when it is reacts with oxygen, then it produces combustion product is water. So molecular weights are, here 2 hydrogen we are taking, so 2 into 2, so 4 kgs totally, and it's required how much amount of oxygen? 32 kgs of oxygen. So water, combustion product molecular weight is 36. So here hydrogen and oxygen both are 1:8 ratio. 1:8 ratio. So here 4 kgs of hydrogen requires. 4 kgs of hydrogen requires how much amount of oxygen for combustion? 32 kilograms of oxygen. 32 kilograms of oxygen required for complete combustion of fuel. So here for complete combustion, H kgs, for example, here taking Y or H, anything it's okay. So here H kg of hydrogen in the fuel. So it requires how much amount of oxygen for complete combustion of fuel. So you can write here 32 by 4 into H kgs of hydrogen. This is most important for numerical calculation purpose, how much amount of air or oxygen required for complete combustion of fuel. So if in case hydrogen present in fuel, if in case kgs of hydrogen in the fuel, how much amount of oxygen required? So how can we calculate this one? 32 by 4 into hydrogen. 32 by 4 into hydrogen, kgs of oxygen required. This is equation number 1. So here, some of the hydrogen also present in the combined form with oxygen. If in case in the fuel, oxygen is present already. So when hydrogen interacts with oxygen, then gives H2O. So in that case, this combined oxygen does not take part in combustion reaction. So this oxygen we cannot consider for complete combustion of the reaction. We cannot consider this one. So here 8 parts of oxygen. 8 parts of oxygen with 1 part of hydrogen. So in this reaction it's given clearly 8 parts of oxygen combines with 1 part of hydrogen. So in this case the amount of hydrogen available for combustion. The amount of hydrogen available for combustion. So how can you write on this one? So it's equal H minus O by 8. If in case oxygen present in fuel, so hydrogen combined with oxygen then gives H2O. So the combined oxygen we cannot consider in this combustion reaction. So in that case you can write if in case the amount of hydrogen available for combustion. So you can write here it's equal to H minus O by 8. H minus O by 8. So oxygen required for complete combustion of hydrogen. So it's equal 32 by 4 into H minus O by 8. We can write here 32 by 4 into H minus O by 8. So this is equation number 2. So now you can, for example, sulfur present in this fuel. So burning of sulfur, so that purpose how much amount of oxygen required. So first you can write the reaction. So sulfur reacts with oxygen, then gives combustion product is sulfur dioxide. So what is the molecular weight of sulfur? 32. So it's how much amount of oxygen required? Same 32. And molecular weight of sulfur dioxide is 64. So here what is the meaning? 32 kilograms of sulfur required oxygen for complete combustion. So 32 kilograms of sulfur required. How much amount of oxygen for complete combustion? It's equal to 32 kilograms of oxygen. 32 kilograms of oxygen. So the given sulfur required oxygen for complete combustion. So S amount of sulfur or fuel, it required how much amount of oxygen, complete combustion of fuel. So here we can write here 32 by 32 into sulfur. So in all these cases, first we can write down the reaction. After that, how much amount of oxygen required for complete combustion of fuel, we can easily identify by taking weights of substances. Next point, and combining the above three combustion equations. That means if in case carbon or hydrogen or oxygen and sulfur present in fuel, when it interacts with oxygen, previously just now we discussed already. So on combining above three combustion equations, so we get the equation for the theoretical oxygen requirement. Theoretical oxygen requirement for the complete combustion of carbon, hydrogen and sulfur. So it's equal. How can we write on this reaction? If in case this by taking above three combustion reactions. So theoretical oxygen requirement for the combustion of carbon, hydrogen, sulfur is equal 32 by 12 into C plus 8 into H minus O by H plus sulfur. So next, air contains 23% by weight of oxygen. So air contains how much amount of oxygen by taking weight? By weight, 23% of oxygen by weight, or 21% by volume of oxygen. So air contains 23% of oxygen by weight, or 21% of oxygen by volume. This is most important for numerical purpose. And next, minimum weight of air required for complete combustion. So you are taking by weights. So what is the formula we are using here? It's equal 100 by 23 because air contains 23% of oxygen by weight. So here we are taking minimum weight of air. So we can write here 100 by 23 into 32 by 12 into C plus 8 into H minus O by 8 plus sulfur. Or otherwise, if you are taking minimum volume of air, here you are taking weight of air, here minimum volume of air required for complete combustion of fuel. So here you can write here 100 by 21 because air contains 21% of oxygen by volume. So 100 by 21 into same formula 32 by 12 into C plus 8 into H minus O by 8 plus S. This is the final formula. These two are most important for numerical purpose. For calculation of how much amount of air required for complete combustion of fuel. If you are taking weight, we are using this formula. If you are taking by volume, we are using this formula. So some of the examples given here. So for example, volume or weight of air required for complete combustion of some combustible matters, for example. We are taking here by weight and by volume. For example, methane, where it interacts with atmospheric oxygen. Combustion products are carbon dioxide and water. So by weight, what is the ratio? 16 and 64. Or by volume, 1 methane and 1 oxygen, 1 part of oxygen. Or for example, sulfur. So 1 part or 32 parts of sulfur or 32 kgs of sulfur, it requires 32 kilograms of oxygen by weight. Or by volume, if you are taking 1:1. 1:1, both are 1 only. Or if in case, for example, carbon monoxide and oxygen gives combustion product is carbon dioxide. So by weight means 28 kilograms of carbon monoxide requires how much amount of oxygen? 16 kilograms of oxygen. Or otherwise, you are taking by volume, 1 volume of carbon monoxide requires 0.5 volume of oxygen required for complete combustion of fuel. These are some of the examples by taking volume or weight of air required for complete combustion of combustible substances. And last point is here, excess of air supply. So it is necessary to supply excess air for complete combustion of fuel. Excess air also required for complete combustion of fuel. So how can you calculate this one? The amount of air required if excess of air is supplied. So it's equal theoretical amount of air by 100 into 100 plus percentage of excess of air supplied. So using this formula, you can calculate the amount of air required if excess of air is supplied. In that case, we are using this formula. And most important points, combustion reactions are, already we know that. So air contains 21% of oxygen by volume and 23% of oxygen by weight. So from the amount of oxygen required for the combustion by the fuel, the amount of air can be calculated. And from the combustion reaction equations, we can calculate the quantity of oxygen by weight or volume. We can calculate in this combustion reactions. Now let's discuss most important point for numerical calculation purpose. So here the following steps must be followed to calculate the amount of air required for complete combustion of the fuel. So here these are the most important steps for calculation of how much amount of air required for complete combustion of fuel. So first one is step 1. So first write down the combustion reaction equation. For example, if in case sulfur present in fuel. So what is the combustion reaction? Sulfur reacts with oxygen, then gives sulfur dioxide. So what is the molecular weight of sulfur? 32. And oxygen? 32. And here 64 molecular weight of sulfur dioxide. So by weight, if you are taking 32 kilograms of sulfur requires 32 kilograms of oxygen. How can we know this one? So by writing the combustion reaction equation. So from this equation, step 2, from this equation, calculate the amount of oxygen required. Calculate the amount of oxygen required by the elements or compounds present in the fuel. So from this equation 1 or from this combustion equation, calculate the how much amount of oxygen required by the elements or compounds present in the fuel. For example, here sulfur and oxygen. So 32 kilograms of sulfur requires how much amount of oxygen? 32 kilograms of oxygen. It is easily understood by writing the combustion reaction. Next, step 3. So what is step 3? If oxygen is mentioned in the problem. Already if oxygen present in fuel, it is mentioned in the problem. So subtract the weight or volume of oxygen already present in the fuel. So what is the step 3? If oxygen mentioned in the problem. So subtract the weight or volume of oxygen already present in the fuel from the total oxygen required by the other elements or compounds. And next, step 4, since for example nitrogen or carbon dioxide and water, so do not burn, they do not require any oxygen if in case these elements present in the fuel or if in case combustion products form. So in this case, since nitrogen, carbon dioxide and water do not burn, they do not have any calorific value, they do not burn. So that means it do not take oxygen for complete combustion, do not participate in this combustion reaction. So they do not require any oxygen. Therefore, their values is mentioned in the problem can be ignored. If in case mentioned these values in this problem, we can ignore because it doesn't require any oxygen, do not participate in this combustion reactions. So what is the first point? Write combustion reaction equation. And next one, how much amount of oxygen required for complete combustion of fuels or elements present in the fuel. Next, third one, if oxygen mentioned in the problem, so subtract the weight of volume of oxygen present in the fuel from total oxygen required by the other elements or compounds. And step 4 is if non-combustible substance present in the fuel, if in case mentioned in the problem, we can ignore because they do not participate in this combustion reaction, so they don't have any oxygen required. So we can ignore. These are the main points. And one more point is next step 5. So finally calculate the amount of air required by the fuel. So finally calculate the amount of air required by the fuel. So it can be multiplying 100 by 21 if volume, because air contains 21% of oxygen. 21%. So you can write here 100 by 21 if volume percentage. Or otherwise total amount of oxygen required by weight. Here we can write 100 by 23. So with total amount of oxygen required. Next step 6. Excess air for combustion. Excess air for combustion. So it is required. So more than the theoretical amount of air is necessary in practice to achieve complete combustion. So excess of air for combustion here, more than the theoretical amount of air is necessary in the practice to achieve complete combustion. So the excess of air is expressed in percentage of theoretical air. So it's equal theoretical air into 100 plus excess of air by 100. We are using this formula. So by taking we consider these most important points for calculation of how much amount of air required for complete combustion of fuel. So before calculation, we can remember all these points. After that starts the calculation. So now let's discuss one sample problem based on this how much amount of air required for complete combustion of fuel. So a sample of coal was found to contain here carbon is 80%, hydrogen is 5%, and oxygen is 1%. And nitrogen is 2%. So remaining being ash. So calculate the amount of minimum air required for complete combustion of 1 kg of coal sample or 1 kg of coal fuel. So here we can, so all these present in this problem given percentage, so we can convert it into kg because 1 kg of coal sample is burning. So all the elements converted into kilograms. So here 1 kg of coal contains. So here carbon, for example, carbon present in this fuel is 80%. So we can convert it into kilograms. So 80 by 100. So it's equal 1 kg of fuel containing 0.8 kilograms of carbon. 0.8 kilograms of carbon. And next 5 by 100 because the hydrogen containing in this fuel is 5%. So it's equal 0.05 kilograms of hydrogen. And in the same way in this problem, oxygen is 1% present in this. So 1 kg of fuel contains 0.01 kilograms of oxygen. And next nitrogen containing 2%. Actually nitrogen present in fuel we cannot consider because it doesn't require any oxygen. Do not participate in this combustion reaction, so you can ignore, but we converted into kilogram. It containing 1 kg of fuel, 0.02 kilograms of nitrogen. So here, what is the solution? 1 kg of fuel containing 0.8 kilograms of carbon and 0.05 kilograms of hydrogen and 0.01 kilograms of oxygen and 0.02 kilograms of nitrogen. So if in case just we discussed already, nitrogen is not combustible constituent. So that means it does not burn and does not require any oxygen. So we can ignore this one. So what is the step 1? And before calculation, what we should remember? So first write in the combustion reaction. Combustion reaction. So if in case carbon already present in this, so write in this here carbon reaction is carbon reacts with oxygen and gives carbon dioxide. So what is the meaning here? 12 kilograms of carbon requires 32 kilograms of oxygen. And next hydrogen also present in this sphere. So first write in the hydrogen reaction, H2 reacts with oxygen, then combustion product is water. So here molecular weight is 2 kilograms of hydrogen requires 16 kilograms of oxygen. So this is step 1. First write down the combustion reaction by taking weights here. And next. So now 12 kilograms of carbon requires, just now we discussed by taking combustion reaction, 12 kilograms of carbon requires 32 kilograms of oxygen. Already we know that by taking reaction. So here, how much percentage of carbon present in this fuel? 0.8. 0.8. So now you can write here 0.8 kilograms of carbon requires how many kilograms of oxygen. So how can you write on this one? How can you calculate this? 0.8 kilograms of carbon requires how many kilograms of oxygen? So you can calculate here 32 by 12 into 0.8. 0.8. So it's equal 2.133 kilograms of oxygen. So 0.8 kilograms of carbon requires 2.133 kilograms of oxygen. And next, for example, 2 kg of hydrogen requires 16 kilograms of oxygen. 2 kgs of hydrogen requires 16 kilograms of oxygen. So that means what is a combustible reaction? So see here, 2 kilograms of hydrogen requires 16 kilograms of oxygen. So in the same way, here 0.05 kilograms already given in this problem. So how much percent of hydrogen present in fuel? 0.05 kilograms of hydrogen. So it requires how many kilograms of oxygen? So you can calculate this one here. 16 by 2 into 0.05. 16 by 2 into 0.05. Already this one is present in this fuel. So it's equal 0.4 kilograms of oxygen required. 0.4 kilograms of oxygen required. So now total amount of oxygen required. So it's equal. So 2.133 plus second one you get 0.4. So here 2.533 kilograms. Total amount of oxygen required is equal 2.533 kilograms. But the amount of oxygen already present in the fuel. It's equal 0.01 kg. Already given in this. See here. The amount of oxygen already present in fuel is 0.01. So net oxygen required. So that purpose we can subtract this total amount of oxygen already present in the fuel from total amount of oxygen required. So step 3. So here 2.533, that is the total amount of oxygen required. 2.533 minus the amount of net amount of oxygen, that means the amount of oxygen already present in the fuel is 0.01. So then we'll get 2.523 kilograms. 2.523 kilograms. So we know that already 23 kilograms of oxygen supplied by 23 kilograms of oxygen supplied by 100 kg of air. 100 kg of air. So 2.523 kilograms of oxygen supplied by, it's equal 100 by 23 by weight we are taking here 1 kg. So we are using this form 100 by 23. Air contains 23% of oxygen by weight. So here we are taking 1 kg of fuel by weight only. So we can write here 100 by 23 into 2.523. 2.523. It is the net amount of oxygen is 2.523. So finally you will get 10.9695 kilograms of air. 10.9695 kilogram of air. So the minimum quantity of air required for complete combustion of 1 kg of fuel. The minimum quantity of air required for complete combustion of 1 kg of fuel is 10.9695 kilograms. 10.9695 kilograms. So in this way you have to calculate the how much amount of air required for complete combustion of fuels. So one more problem we'll discuss based on this only. So how much amount of air required for complete combustion of fuel. So first, what is the step 1? Before calculation, we should remember. So what is the step 1? First, write down the combustion reaction. Next, second one, how much amount of air required by taking molecular weights. And third one is, if in case already oxygen present in the fuel, we can subtract that oxygen from total amount of oxygen required for complete combustion of fuel. And after that, if you are taking by weights, we are using 100 by 23 and remaining formula. If you are taking volume, we are using 100 by 21 into remaining formula. So we should remember that points, and after that we can calculate the how much amount of heat required for the complete combustion of fuel. So now one more problem we'll discuss based on that. So what is that? Calculate the minimum amount of air required. Calculate the minimum amount of air required for the complete combustion of 1 kg of fuel containing. For the complete combustion of 1 kg of fuel containing. So here carbon equal 80%, hydrogen is 6, oxygen is 8, sulfur equal 1.5 and H2O equal 1% and nitrogen equal 1.5%. So these are present in this percentages, these are the elements present in this percentage in this 1 kg of fuel. So here we are taking 1 kg, so we can convert it into kilograms. So here what are the constituents present in this fuel from the given the data? So carbon, so its weight is here it given by percentage is 80. So we can convert it into kilograms, we can get 0.80. And hydrogen is present in this fuel is 6% and its percentage we can convert it into 0.06 kilograms. And oxygen, sulfur, water and nitrogen present in this fuel already given in this data. So what are the percentage present in these elements? 8, 1.5, 1, 1.5. So we can convert it into kilograms. Then we will get oxygen percentage is 0.8 and sulfur percentage is 0.015 and next water and nitrogen also present in this. But if in case is present in fuel, we cannot consider because these are not participated in this combustion reactions. So here does not contribute to this to our because does not require any oxygen and do not participate in this combustion. So we can ignore these two. Does not contribute in this combustion reactions. Now you can calculate how much amount of air required for complete combustion of fuel. So before problem already we discussed by weight we are taking. So we can write here 100 by 23 into direct formula you can write here because just only we discussed all this. So 100 by 23 into 32 by 12 into C. If in case 12 kilograms of carbon requires 32 kilograms of oxygen. So in the same way carbon, C kilograms of carbon requires how many kilograms of oxygen. So we can write here 32 by 12 into C, just now we discussed already. If in case hydrogen present in that, so we can calculate the hydrogen 8 into H minus O by 8 plus sulfur. So by using this formula, we can calculate how much amount of air required for complete combustion of 1 kg of fuel. So here we can substitute this carbon, hydrogen, oxygen and sulfur values in this formula. So finally we get 100 by 23 into, so here 12 by 32, 2.6 I will get. So 2.67 and carbon percentage given in this data. So how much percentage given? 80 or 0.80. So we are taking 0.80 plus 8 into hydrogen percentage given in the fuel 0.06. So we can substitute here minus 0.08 is the oxygen percentage present in the fuel given in this data by 8 plus sulfur. How many kilograms of sulfur present in this fuel? 0.015. So we can substitute all the values in this formula. Then we'll get, after calculation, we'll get 100 by 23 into 2.136 plus 0.4 plus 0.015. So after addition, we'll get 100 by 23 into 2.551. 2.551. So after calculation, finally we'll get 11.0913. So the amount of oxygen or air required for complete combustion of 1 kg of fuel is 11.0913 kilograms. So in this way, you can calculate the how much amount of air required for complete combustion of fuel. So in this session, we'll learn about how to calculate the how much amount of air required for complete combustion of fuel. What are the steps involved? What we should remember before the calculation? So all we discussed in this session. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.